So let's talk about adding and subtracting fractions, which is going to lead us into adding and subtracting rational expressions. So the steps for adding and subtracting fractions you should know from earlier math classes, obviously. You find a common denominator, convert the fractions to the common denominator, and then add and subtract numerators and keep the denominators the same. If you need to write down those steps, you might want to pause the video and do that. Put those in your notes. All right, I wanted to start with an example that's just numbers, so something that you would have done before. So here we have denominators in the yellow example of 16, 42, and 24. And what we're looking for is a number that all three of those will go into evenly. Now we could take 16 and multiply it by 42 and multiply it by 24, but that would give us a really big number, and we would end up having to simplify the fraction at the end. And remember, we're doing this so we can sort of do problems like the blue problem on the right. And if we just multiply those denominators together in the blue problem, we would have this huge polynomial, and then we would have a lot of multiplication to do on top and bottom, and then we would have to do some simplification at the end, and it would be a lot more work. So what I want to do is to guide you through an efficient process to find the least common denominator. And the idea behind this is you were looking for a number that divides, each 16, 42, and 24 divide evenly into, which means when you look at the common denominator that we're going to get, you should be able to see the exact same factors you see in 16, in 42, and in 24, but not in excess. That's what makes it the least common denominator. So what I'm going to walk you through is a process called the pool method. So what we're going to do for the pool method is we're going to start by factoring all your denominators. So we're going to take 16 and break it down into 2 times 2 times 2 times 2. We're going to take 42, that's 2 times 3 times 7. And we're going to take 24, and that's 2 times 2 times 2 times 3. Then what we're going to do is we're going to build a pool. Now let me explain how this is going to work. So let me write my LCD pool here. So what I want to do is build the smallest pool of factors that I can reach into and grab any of the denominators at any point. So the first thing I'm going to do in building this pool is I'm going to take my first denominator, which are these 4 2's, and I'm going to throw all those 2's into the pool. Whoops. So we got 2 times 2 times 2 times 2. Now, that means if I reached into the pool right now, I could reach out and grab that 16. So I'm going to move to the second denominator. In the pool, I need a 2, a 3, and a 7. I already have a 2. I don't need to add another one. All I really need to do to be able to reach in and grab the 42 is to toss a 3 and a 7 into the pool. So now I could reach in there and grab 16 if I wanted to. I could reach in there and grab 42. So now I go to the last denominator. I need 3 2's and a 3. Well, if you look at the pool we've got, I already have 3 2's and a 3. I don't need to toss anything else in there to be able to make the LCD. Once I've done this process with all the denominators, in this case there are only 3 of them, what's in the pool is my LCD. So let's see, that would be 7 times 48, which I think is 336. So that means my least common denominator in this problem is 336. So I'm going to go ahead and write that common denominator down for all the fractions. Now, here's one of my favorite parts about the pool method. When I go to get the numbers, because I need to convert the fractions to be over the common denominator. So here's how this is going to look. I'm going to go back to the original factored denominators that I have, so like the 2 times 2 times 2 times 2. And I'm going to ask myself, what is missing from the common denominator? So I have 4 2's here. The common denominator has 4 2's, a 3, and a 7. So I need to multiply this denominator by 3 and by 7 to make it the common denominator. But if I do it to the bottom of that fraction, I also have to do it to the top. So then 3 times 7 times 5 is 105. And then you do the same thing with the other denominators. I go to the second one. I already have the 2, 3, and the 7. That's the 2, 3, and the 7, so I need 3 2's, which means I have to do the same thing to the top. And then the 24, I have the 3 2's and a 3, 3 2's and a 3, so I need a 2 and a 7, so I need the same thing on the top. Oops, sorry, not 108, that's 98. And then I'm ready to actually add and subtract the fractions. So remember, when you're adding and subtracting fractions, you keep the denominator the same. And you add and subtract the numerators. So I think that comes out as 95 over 336. And if my fractions were all simplified to start with, and I found the LCD, the fraction that you end up with at the end there should be fully simplified. So let's talk about what this looks like with rational expressions now. Exact same process. We're going to start by finding the LCD by building the pool, and we start building the pool by factoring the denominators. Then we're going to take the factors from the first denominator and we're going to throw them all into the pool. So now we can create the first denominator out of the pool. And then we go to the second denominator and say, what do we need to be able to make that out of the pool? Well, we already have an x plus 1. We need the x minus 5. So there's my LCD. So I'm going to write that down. Okay. So then again, I'm going to look back at my original denominators, the factor forms, and I'm going to say what's missing to make it the LCD. So this first denominator has the x plus 1 and the x plus 2. It needs the x minus 5. So I'm going to do the same thing to the top of the fraction. The second denominator has an x minus 5 and an x plus 1. It needs the x plus 2. So I do the same thing to the top. By the way, we still have to think about excluded values on these things, but I could look at my least common denominator and get the excluded values from there, because those are going to be the denominators of my fractions, right? So x could not equal -2, or -1, or 5. So now I'm ready to subtract the fractions. So one of the things that I like to do, because it's really easy to make sign errors on these, is when I do the subtraction step, I'm going to be a little bit lazy here. I don't want to rewrite all these three factors out right now. So I'm just going to write the letters LCD, and I'm going to bring the common denominator back. You are free to do that. But I'm going to write 5x minus 25, which is from the first fraction, in parentheses, and then subtract the top of the second fraction in parentheses. That means when I write it like this, it sort of draws my attention to the fact that both the x squared and the 2x from the second fraction have to be subtracted. So now I'm going to do that subtraction. So that, oops, didn't mean to put a comma there. That would be negative x squared, and then we have 5x minus 2x, which is plus 3x, and then negative 25. And then remember I mentioned in the problems that we were doing before, I'd like your answers to be multiplied out at the end. So I'm going to take the x plus 2, x plus 1, and x minus 5 and multiply them. X plus 2 times x plus 1 is x squared plus 3x plus 2. I'm going to multiply that by x minus 5. This is my least common denominator that I'm going to put under each of the fractions. So let's see, I'll fill in my box. And combine like terms. So we got x cubed, we got negative 2x squared, we got negative 13x, and we got negative 10. So this would be my fraction, and then at the end, to finish off my answer, I'd write the excluded values. So remember, start by factoring the denominators, use the pool method to get a least common denominator, convert the fractions to that common denominator, and then add and subtract the numerators. Keep the denominators the same, and don't forget your excluded values.